Today's video we'll be using the mini mill to bore a hole through a pair of 1/2 inch thick steel plates, and then using those plates on the hydraulic press to press a shaft into a bearing or into a sleeve. So we'll go ahead and get started with that. I'm working on this boring operation. I'm boring a hole 66 millimeters diameter, which is about 2.6 inches, and it's in two steel plates which are butted together. And these are going to be support plates for use on my hydraulic press, and I'll show you a little later in the video what they're going to be used for. But I'm pretty well along in the boring process, and I started out roughing out the hole on the bandsaw so I didn't have to bore the whole thing out. I guess that's a pun. Anyway, so let's see how the mini mill works on this job. As you can see, there's some chips already in here, so I'm getting close to the final diameter, but you may also see that the chips are blue colored in many cases, which indicates they're getting very hot. What I'm using is a boring head with a one of those low-cost sets of carbide cutters in there. But I've also sharpened the cutter and adjusted the angles on it using my mini lathe. You probably know that the conventional way to sharpen carbide tools is to use what's called a green wheel or a silicon carbide wheel on a bench grinder, but I don't have one of those and didn't really want to spend the money to get one and tie up one side of my grinder just for that purpose. But what I've been using just for these little touch-up jobs like this is this diamond wheel from Harbor Freight, and then I made an arbor for it so I can mount it in the mini lathe. And I've got a paper towel here just to catch the carbide grit that comes off of here. So this is a industrial diamond surface on here, and it will shape and cut the carbide pretty slowly, but that's good because it gives you good control over the final shape. And just as with any cutting tool, you want to create a little bit of a clearance edge here so that the tool does not rub on the side of the workpiece. And it takes a little practice to get used to holding these at the right angle, and then I just move them slowly back and forth, or you can even hold them steady. Seems to work pretty well too. Anyway, that's just a tip for those of you who may be looking for an inexpensive way to sharpen your carbide tools. So it puts a pretty good edge on it. Now for the clamping setup, I have the two steel plates placed on top of a sacrificial piece of masonite or 1/8 inch MDF, and that's so I can bore down past the bottom of the metal plates without boring into the surface of the mill table. Now I've got these two clamps in place and two 1-2-3 blocks to hold everything together. So it's a circle, but it's really two half circles, one half circle on each plate. So I'm going to advance the tool by just a 1/4 turn here, and that's I think it's 50 thousandths. One turn is 50 thousandths. 1/4 turn is about 12.5, and so that should increase the diameter by twice that, which will be 25 thousandths. I'm cutting to a metric target, but of course the boring head here is calibrated in thousandths of an inch. I've got these plastic shields in place, and they're just two pieces of acrylic plastic that are bent into an L shape, and I use them in a lot of different configurations, but in this case they're just resting here on the metal plates, and that helps to confine the chips to that space inside the shield there. I'm just feeding the head down using this 3-spoke hand wheel. Okay, and I'm not using any cutting fluid. Earlier I was using some dark brown sulfurized pipe cutting fluid, but it was producing a lot of smoke. Since my shop is connected right to the main part of the house, I don't like to produce smoke if I can avoid it. But let's get some of those chips out of the way. I'll use a snap gauge here to take a reading of the current diameter, see how close we are to our target, which is 66 millimeters. We're very close, actually a little bit over. We're about 60, almost 68. Well, that's okay, I may just call it done. Fortunately, the dimensions on this are not at all critical, so plus or minus, 4 or 5 millimeters is fine for what I'm doing here. I'm going to go ahead and take this off of the mini mill and take it over to the hydraulic press. These little clamps I got a while back from LittleMachineShop.com, and I like them better when I can use them. I like them better than the standard strap clamps, just because they're quicker and easier to set up, as you can see, or take down in this case. Got some very sharp edges on here, so I'm going to take a deburring tool and clean those up a little bit so I don't cut myself. You can see some saw cut marks here where I rough cut it out on the bandsaw. I guess I didn't do a very careful job of that because the cuts went in a little deeper than the final bore, but no big deal for what I'm doing. This is a little deburring tool from Noga. Works real well. Not too bad. I need to take a file to these sharp corners here too. I did the rough cutting on my Harbor Freight 4x6 horizontal vertical bandsaw, and I got this back in 1999, and I've done quite a few modifications to it over the years, and one of them is making this vertical table, which is quick and easy to set up and much bigger, much more effective than the stock table that comes with it. If you've ever had one of these or seen them, they come with a little cheap stamped sheet metal plate to be used as the vertical table, which is pretty close to useless. But I have a nice setup here now. Got a bench and some other features that make this bandsaw really nice and easy to use. So for this particular job, I set it up on here and I did a rough cut. I cut out sort of a triangle shaped piece here, just so I wouldn't have to remove all that metal using the boring tool. What this project is really all about is finishing the repair of this spindle, which is from my Sieg SX4 mill. It's a benchtop mill, and it's quite a lot bigger than the mini mill, and I've had it for, I don't know, probably 10 years or more. But one of the bearings, the bearing down here in the bottom, I guess it was, went out, so I took it all apart and I replaced both of the bearings. There's actually 3 bearings in there. There's a thrust bearing, a roller bearing, and a taper bearing. So I replaced the roller bearing and the taper bearing. But the problem is now I need to press the spindle back into the bearing so I can reassemble the mill and see if it all works right. And to do that, I need to use the hydraulic press. So I've got this 20-ton Harbor Freight hydraulic press, and of course, like everything else in my shop, I've done some customizations on it. Put this little flexible gooseneck lamp on here so I can see what I'm doing. This is a little handle I made on the lathe. You end up having to manipulate this handle here frequently while you're using the press, and it's kind of literally a pain to operate because it's sort of sharp for the amount of pressure that you have to put on it. So this just pops on there, or you can take it off if you want to, but it makes it a lot easier to operate that valve. And I've also mounted some aluminum L on these 2 parts of what we'll call the table here that holds these things in place, and that just keeps them from sliding off onto your foot, because if you drop one of these on your toe, If you're not wearing steel-toe safety shoes, you're probably going to be looking at a broken foot at least. I've just made a little spring clamp to hold the handle that's used to operate the hydraulic jack. So that just is a handy place to keep that when it's not in use. And then over here I have a little tray, and I've made various tools that I use when I'm pressing bearings in or out or various other things. And so these are just some things I made on the lathe, some more over here that come in handy when you're trying to press things. Another tip that I saw from another person, don't remember who, is a lot of times you can use just a socket as a tool to press them. If you have socket sets, and of course most of us have several, you can often find a socket that will be just the right size for pressing a bearing in or out or some other job. The press comes with these two cast iron plates, and they have various shapes cut out on them, and the idea is you can put them together here to drop something down through there that needs to be pressed down through. Not a bad idea, except that in this case the holes that are on here, none of these holes really fit the job that I'm trying to do, so that's why I made these special plates. Alright, with all that said, I've got my new steel plates in place here, and I can drop my spindle down in there, get it lined up with the ram for the hydraulic jack here, and then we'll see if we can get this job done. Now here's a case where these little spacers come in handy. I can stick that in there. And the reason is that when you operate the jack, each pump of the handle only lowers it by, I don't know, maybe 1/8 of an inch or something, maybe not even that much. So it takes a lot of pumping to get it down this far, and then about the time you get it down there, you realize it won't go any lower, and then you have to start over. So you can move the table up or down, but the increments are probably about 5 inches or so. So anyway, it's handy to have some spacers like this that you can use to fill in that gap. Sometimes I use more than one, and that just saves a lot of pumping. So let's go ahead and see if we can press this thing into place. And there it goes. It's pressing down into the bearing. Okay, now I'm feeling resistance on the handle, so I know have pressed it as far as I want to go. So we'll just take this out, and now we'll take it out and make sure everything turns the way it should. Well, I'm testing it. It feels a little tight. I may have pressed it in there a little too far, so there's a thrust bearing in there, and I may have too much pressure on the thrust bearing, so I'm not sure exactly what's going on, but it doesn't feel as smooth as it should. Now I did find that the bearing, a taper bearing that I bought off of Amazon, that theoretically is an exact replacement for the original, in fact had some very minor differences. And there was this black sleeve that comes down on here. I actually had to turn the edge of it down a little bit on the lathe because it was hitting the side of the bearing, so maybe something to do with that. But I'll investigate it, but that's a story for another day. Well, thus ends another episode of Work in the MiniLathe.com shop. I hope you found a few tips in there that you can apply to your own work. And thanks for tuning in. We'll see you next time.